doing the inscribed angle theorem today. So what that's going to look like is we're going to narrow it down to 3 cases. So the first one is when we have that CAE is the diameter of the circle. And so ultimately what we want to get to in all of these is to show that angle EAB is double that of angle BCE. So the first way we're going to show is when this is the diameter. And so what that means is CA is the same length as AE as well as AB. So what we have here is an isosceles triangle between, or right here, and also an isosceles triangle right here. So we know that this angle, angle C, is the same as angle ABC, and also that ABE is the same as AEB. So these angles right here are congruent, and so are these. So this angle up here, since this is a straight line, since the diameter is going to be 180 minus whatever this angle is here. For now, I'll just call it theta. And so for these other angles that are equivalent, we know the angle total of a triangle is going to be 180 degrees. So we have 2 of these. So 2 times, we'll say angle C, plus, and we have 180 minus theta is going to equal 180 degrees. So then, because we have 180 on one side, 180 on the other, we can cancel those out. So we know that 2 times angle C minus that is going to equal 100, or is going to be equal to 0 then, because the 180 is canceled out. So if we add this angle over to the other side, we get 2 times angle C is going to equal this angle here, theta. So we know that 2 times this is equal to this. Therefore, angle C is half that of this angle here. So another case we have is if we move C here and it is no longer on the diameter. However, we can still draw a diameter. So let's draw it like this. Through A, draw it like that. So in a lot of these we can use what we've already learned. So in this case, we know this angle, these 2 angles might not always be the same. So we'll call them things different. So like theta 1, theta 2, E. So we can use the same reasoning we did the last time in order to also narrow it down for this. So we have this triangle here. Let's make that a different color. Make it red. We'll focus to this side, and we prove it on this side. It will also work for the other side. So we have the exact same thing where we have this angle here, called angle theta, and we have, and this looks very similar to how we just had it when it was like our diameter like this, ignoring the line, or ignoring this line. So we still have that. And so we know that this angle here is half of this angle, angle EAF, or EAD. So then we can also say that for the other side, where it's DAB, this angle here, is double that of angle DCB. So we combine those, we have 1/2 of this angle, this is 1/2 of that angle. So if we add these angles together, then, and we add these angles together, these should still be half of this amount here. And now we can move to the last case. The last case is like this. Let's get rid of that. Oh no, we want to keep that. We want to get rid of that. Okay. So now this looks a little different. We have like an hourglass shape right here. But what we can do is draw another diameter. We'll say that's the diameter like that. Nice. Okay, so we then have this triangle here. We'll color it in. Make it stand out. Okay. So again, we have what we see. So here we have our third case where we now have drawn the diameter for CAF and our CEB and AEB. There we go. Are our two triangles we're working with. So, oops, let's go over here. Now I'll fill this in, call it red. Okay. So let's look at it this way. We have this angle right here. This angle ECF. It's a big angle that goes across the circle. And we also have this angle FAE. So we know that FCE is half the measurement of FAE from our first case. And so we also see that we have FCB, we have FAB. And we know that from our first case that this angle here is going to be double that of the angle here. So we have those equivalencies, and then if we subtract this angle from this whole side, we're left with this. If we subtract this angle from this whole side, then we're left that this EAB is double the length or the measurement of this whole angle ECB. And those are three cases for the inscribed angle theorem, and that is the proof for them. So thank you for your time. Have a good day.